Now, in this lesson, we're going to review this idea about magnets and how magnets are made. Let's read the question together. Sally coiled a wire around a metal nail. Both ends of the wire were attached to a battery. What does she mean here? Right? She coiled wire around the metal nail and both ends of the wire were attached to a battery. Right, let's see, did she attach them correctly? So one end of the wire is connected to the minus sign part of the battery, the negative side, and at the positive side of the battery here there's another wire attached to it. So I can tell that this wire has been connected properly, correctly, and an electrical current should be able to flow through this wire. Then there's a metal ball bearing was placed near the metal nail such that the nail was within the magnetic field region. Now ball bearing is just think of it as a metal ball, don't care about this bearing. So this is a metal ball. Now take note that the word here is metal. Alright, and there are different kinds of metals. Some metals are magnetic. Some metals are non-magnetic. Magnetic materials, metals that are magnetic are things like iron and steel. Metals that are non-magnetic could be aluminum, could be copper, or anything else. So let us be very clear. We do not know whether this metal ball can be attracted to the electromagnet or not. By now you should be able to tell this is an electromagnet. Right? We should be able to tell. Will it be attracted to it or not? We will know until we see the observation. Similarly, there's a metal nail here. Now, this electromagnet will work if this nail is a magnetic material like iron or steel. If it is a non-magnetic material like copper or aluminum, then even if current can flow through, this will still not become an electromagnet. So far, what we have done is trying to understand this picture, this story, and all the clues that have been given to us. So, only after this can we go to the question. This part here is not the question, this part is just a story. And then her observation is the metal ball bearing was not attracted to the nail. So there could be two possible problems. It could be, or could be more. Maybe both of the metals are made of non-magnetic materials. Or maybe this metal nail is made of a magnetic material, and this one becomes an electromagnet. However, if this is a non-magnetic material, there will be no attraction observed. That will be the second possible reason. The third possible reason is this is a magnetic material, iron or steel, but this metal nail is made of a non-magnetic material, so it does not become an electromagnet. Let's see what are the options given to us. Which of the following could be the possible reasons for Sally's observation? So we're trying to find out options that tell us, yeah, this one will not work as an electromagnet because of the wrong material chosen for this metal nail, or because we want to find out whether the problem lies with the metal ball, that this is made of a non-magnetic material. So the nail was made of iron. No, this is not a problem. If the nail is made of an iron, then this tells us that this becomes an electromagnet that works. So this cannot be the possible reason for the failure for Sally to see any attraction. The wire made of copper. This is not a problem. This simply tells us that the wire is made of metal, and metal is a good conductor of electricity, so electrical current can flow through this circuit. This is not a problem. The metal ball bearing was made of aluminum. Metal ball bearing made of a non-magnetic material like aluminum. Yes, this is a possible reason why this attraction was not observed. There were not enough coils of wire around the metal nail. This is also a possible reason. Why? Because when you are typically asked this question, how to increase the magnetism of an electromagnet, you have two possible answers. One is increase the number of coils around the metal nail, or increase the number of batteries. In this case here, if there are not enough coils of wire, that means that the electromagnet may not be strong enough. This seems metal is quite heavy, you know. So now we have it is C and D. Therefore the answer is C and D. If you have any questions, do leave them in the comments below and I will answer them when I see the comments. Let's go to the next page. Susan had two metal rods B and C of the same size. Metal rod B, metal rod C. Remember, we're trying to understand the story first. We will usually not look at the question, right? Let's understand the story. Now, one of these rods was a magnet and the other one was made from a magnetic material. So only one is a magnet. Now, she wanted to find out which rod was a magnet. Now, this is an important and yet very commonly asked question. What does it mean then? It means that you should memorize the idea behind this and know how to answer this instantly. How do you tell whether a magnetic material or an object is a magnet or not? You must see an observation. Please write this down. And this observation that you should see, can you pause the video here and write it down first on your own, and then you check back against my answer. Have integrity, okay? Just pause it and try it first. So, do you write down repulsion? If you have written down repulsion or repel, that means hooray, you got the right idea. If you have written down attraction, then I'm sorry, you need to revise this topic. She arranged the rods B and C, these two rods, and the magnet PR is a magnet PR. Here is PR this way. That means that this person, Susan, actually rotated this like this way, turn it around, and put it over this side, as shown in the diagram below. Now, Susan was not able to conclude which rod was a magnet from the above setup. So what did she do that was wrong? Right? Choose the correct step she should follow to help her make her conclusion. Now, what could have happened? For example, let's assume this is the North Pole. If this is a North Pole, P is a North Pole, then this is a North Pole. If this is a North Pole, then R is a South Pole. If R is a South Pole, therefore this is a South Pole. Now, she noticed that there is an attraction here. Alright? If let's say B is a magnet, then this must be a South Pole. Isn't it? If there's an attraction, this must be a South Pole. And if she twists this magnet, she turn it around like this and put it here. What if C is the non-magnetic material? Sorry, what if C is the magnetic material? So the whole thing, any part of this can be attracted to a magnet. Of course there'll be attraction. So by looking at this, she can't tell which of the rods is a magnet. Because Susan didn't understand the idea that she must observe repulsion. Help her. So based on the answer at the back of this worksheet, which you must have seen, alright, the answer is 3. Alternate the poles of both magnets to the rods and observe any repulsion. So after doing this, what Susan should have done is, for the same rod B, after she put the magnet here, and notice, oh, there is an attraction. So she should turn this around. When you turn it around, it is like this. You have this, now it's S here, and N here. And if this is truly a South Pole, then there must be a repulsion. Then she will know that metal rod B is actually a magnet. If that is true, when she turns this one around, so this one becomes a North Pole and this one becomes a South Pole. If this is truly a magnetic material, no matter how she turns this, she will always observe an attraction. Right? That's why the answer is 3. Next. Last question. Now you're supposed to stroke So it's not the last question, sorry. Stroke WX. So bar WX is made of a magnetic material. Now Sarah magnetized the bar by using the stroke method as shown in the diagram 1 below. So when you see the term magnetic material, you must know that this means that this material can be attracted to a magnet, but it itself is not a magnet. So indicate the magnetic poles of bar WX in diagram 2 after it has been magnetized. So there's a before, there's an after diagram. So I'd like you to write this down now. You can use any color pen you want. Before and after. Okay? So if this is supposed to represent my magnet, what this person is supposed to do, Sarah is supposed to do, is to keep stroking this way, using the same pole to stroke in the same direction. See? From left to right, left to right, left to right, left to right. So if this is truly the south pole, it should be attracting something that is north. Alright? So once it attracts north, you'll drag all the way. There's a north part here, the south part. I know this part you may not understand too much about the magnetic dipoles. I'll try to send you a video to explain this further. Something with graphics from something I can find on YouTube. Just take note that if this is south, you will always attract north. Because remember, unlike poles, attract or repel? Come on. Attract. So if this is south, then therefore you will definitely get north here. Attract, drag across. So if this is not south but north, what will you get here? Of course, you will get south. Sarah then placed steel. I see the word steel. Remember earlier on in our revision, steel is a magnetic material. So she placed pins one at a time at 3 different parts along the bar WX after it has become a magnet, labeled P, Q, and R. PQR. So this is at the 2 poles of the magnet. She continued doing so until no more pins are attracted to the bar WX. The diagram below shows the outcome of her experiment. So there are a few ways to understand this. What can she conclude from her experiment? Now, be very careful. We should call this part pole. This part is a pole. Pole is correct. Can you please write this down? Make sure you put a tick there, because now you're going to write down the wrong answers as well. Don't write things like N. This is questionable. Sometimes if we are going to be lenient, we may accept it, but this is not the proper name for pole. It is like my name is Mr. Long. If you call me teacher, I can choose not to respond to you because I have a name. Teacher is not my name. Teacher is my occupation. What is definitely wrong would be you say sides. Alright, side. Because there can be many sides to a bar. If this is a bar, this can be a side. This can be a side. This one. Alright? There can be 6 different sides to a cuboid. This is a cuboid. So don't use sides. Make sure you have written down all these options, and the only correct one is pole. Now, one conclusion definitely will be this. Number 1, a magnet is strongest at the poles. There are 2 poles, right? So write down poles. You can also observe the middle portion. The second conclusion that you can have is this. A magnet is weakest at the center. Now I know a few of you mentioned that P is stronger than R, as in the pole P is stronger than R. That is also possible, but I'm not going to write this down, okay, because not because it's wrong, it is correct, but I just want to focus on these 2 because these are the 2 typical and understandable concepts that you can apply to all magnets. Whereas whether this pole is stronger than this pole or not, it just happened that it is true in this example. Next one, question 4, last question. Shalisa used an iron nail, batteries, wires, and a switch for an experiment. The diagram below shows an experimental setup. So this is familiar: battery, wires, coil around a nail, and we must highlight the material. This is an iron nail, and if this is this whole setup is, what do you call this whole setup? It has a name to it. What is this whole setup? Try saying it. I'm not going to fill in the rest, alright? Because you should know what is this. 2 words. This whole setup will create this thing. Now, iron nail tells you this is a magnetic material. So let us be the smart lazy. Write it down this way. Magnetic material, our short form that we can learn to take notes. There's also a switch here. She placed steel pins. Again, I see the word steel. Steel is another mm. What is mm? Magnetic material. She placed the steel pins near to the iron nail, which has become magnetized, hopefully, and recorded the number of pins that were attracted to the nail. She repeated the experiment 3 times and recorded the average of the pins attracted. Now, this purpose here, you have learned it from primary 3, okay? You should know. By repeating experiment 3 times means that you... What is the purpose? Write this down. Purpose is to find out if the results of an experiment is reliable or not. And she recorded the average of the pins attracted to the nail. Now this idea could be a new one to you, this part, the average of the pins attracted to the nail. I will explain it a little bit here. I'll try to do it again next time in a proper lesson. This is the first time that you probably come across this. This is to increase the accuracy of her results. What do you mean? For example, let's say if I try something for the first time. Let's say for test number 1, Mr. Long managed to score 10 upon 10. Hooray, my mother said I'm very good in science. Test number 2, I got 5 upon 10. Boo-hoo. Now my mom said that I'm not doing very well in science. I didn't study, I'm lazy. But then it's not true, I did study. It just happened that day, I don't know what happened to me. I was just careless, or I didn't sleep well. Test number 3, I got 10 out of 10 again. And my mom now is very sure that actually I did study, I did do well for science. It's just that this is a flip result. Because by looking at this and we average this out, 10 plus 5 plus 10 is equal to 25. There are 3 different tests. 25 divided by 3 is roughly 8. That means that out of 3 tests, I'm getting 8 out of 10. That is a pretty good score, isn't it? So that would indicate that I am not bad at science. That's the idea of the averaging. So we can help to manage problems that could be due to carelessness, such as this. If the majority of the results give us something similar. She continued the experiment by increasing the number of batteries for each set of 3 trials before recording the results. The graph below shows the results of an experiment. So when she used 1 battery, she will put the the pins near to the nail. She will then record down how many were dangling down. This is something like doing this. But instead of putting pins at the end of the nail, but this is a magnet. We try to see how many get attracted to this, like this, for example, like this. How many get attracted to this? Okay, with 1 magnet, maybe she got 1 battery, she got this. Then later on, she put 2 batteries, another 1. And now she realized, hey, the number now increased. Another pin, another pin, another pin. Right? Now, what was the aim of Shaliza's experiment? To know the aim, we must know what variable has changed. The aim, the clue to find this is in the changed variable. So what was changed? The number of batteries were changed. You see, keep changing. For example, 0 here, 1, 2, 3, 4, 5. Therefore, and what were the results that were being measured? Results were average number of pins attracted. So, to find out if the number of batteries used will affect. Now, this next part is tricky, right? This part really is tricky. A lot of students will get this wrong. A lot of you, if you can get the first part right, hooray for you. But the second part, you're likely to just write this down. Average number of pins attracted, because it is printed here on the worksheet. However, that is not the aim. Now, what does this tell you? If a magnet here can attract 3 pins with 1 battery, and when you put like 5 batteries, it can attract 20 pins. The number of pins attracted tell you how strong the electromagnet is. I repeat, the number of pins attracted tells you how strong the electromagnet is. Therefore, the aim for her, Shaliza, is to find out whether by increasing the number of batteries, will she be able to increase the strength of the battery. So to find out if the number of batteries will affect the strength of the electromagnet. That is the aim of our experiment. Remember I told you earlier on that this part here, this idea will always be tested when it comes to magnetism. How will it increase, how will you change the strength of an electromagnet? Increasing the number of batteries is one way, by increasing this. And how do you tell that it has increased? Well, by observing pins attracted to it, for example. So take note, this is the answer for part A. Next, why did she take the average number of pins attracted to the nail for every battery that was added to the experimental setup? I've given the answer here already. This is the answer. It is to increase the accuracy of her results. Okay, I'm not going to rewrite it as like this for part B. Last but not least, part C. What can she conclude from her result? Conclusion, okay, is always an answer to the aim. What's the aim? To find out if the number of batteries used will affect the strength of the electromagnet. More batteries, strength of the electromagnet increased, because more pins could be attracted. Therefore, that must be the conclusion. As the number of batteries increased, the strength of the electromagnet increased. And that will be the answer for this. Complete the correction? All the best.